Um, Hello everyone. Good evening. Sorry. Okay. Thank you for joining today's session. So sorry about the little delay. Um, Please, I want us to share the location where we are all joining. I am joining from Ibadan, Oyo State, Nigeria. So please, let's share where we are joining in the chat box while we are waiting for others to join. And I really hope we had a great day today at work, and I hope we are looking forward to this insightful study session whereby we'll be sharing, one of our speakers will be sharing great insights about um, a particular topic. So please, as we await others to join before I introduce our speaker, I would like you to share the location where you are joining, and I hope I will be introducing us. So in the next 2 to 3 minutes, I will introduce the speaker and also welcome people joining. Once again, thank you for joining this study session, and I want you to be ready to get a very insightful session from one of the best speaker that have been opportune to listen to, and is a great one that is coming on board to give us today's talk, which topic is on overview, new storage for AI, ML, EFS, and archiving. So I'm here to see anyone respond to my message. Is it that no one has joined? Yeah, I'm still welcoming everyone joining us for today's session. Um, Please, let's share where we are joining from, and if there's um all right. Okay, right. I'm seeing message now. Thank you, Bolaji Aditoye from UK. Oh, that's nice. That's quite far from here, but it's glad that we can be in the same session this moment. Thank you for joining. It's really nice having you. Similarly, and thank you, Ejiro, for welcoming everyone. We are still anticipating people to join so that we can have quite a number of people to benefit from what our speaker today will be sharing with us. So please just give us few minutes to allow some people join in, and we will. Okay, okay. I'm still expecting our message. Okay, okay. Um, Sorry, just a minute to correct something. Um, All right, sorry for that. So I'll be introducing the speakers soon so that we can start this session we are so that we'll have enough time to um have an interesting session with our speaker. Okay, so permit me to introduce our speaker for today. Permit me to introduce our speaker for today, who will be speaking on new storage for AI and ML, that's artificial intelligence and machine learning, EFS, and archiving in person of Ukeme David. And Ukeme David is a DevOps engineer, and he is one that is a very skilled professional with a promising future as a leader in the cloud DevOps engineering development and blockchain development. He has a strong track record in the industry. He possesses over 4 years of experience in web development and more than 3 years of experience in multimedia. He is very passionate about leveraging technology to make a positive impact. He actively seeks opportunities to utilize his expertise and drive innovation. He is committed to solving real-world problems through the application of cutting-edge solutions. He is motivated, talented, and forward-thinking. He is always ready to take on challenges and contribute to projects that make a meaningful difference. For today, really, I am glad Ukeme for joining us today. I am a living witness, if I can say. I've had the opportunity to listen to Ukeme, and really, aside from the quality content that he gives, I really love his vibes, and I want our audience to take note while Ukeme is giving his presentation. You'll see how his vibes relate with what he's trying to teach and how it helps it to sing to people listening. So, without further ado, and not wasting much time due to time factor, I would like to bring on our speaker for today, Ukeme David, to speak on the topic he has. Thank you. So, you have the floor. Thank you. Thank you very
Thank you so
much.
much. Thank you so much, Abdul Latif. It's an opportunity to impact, an opportunity to also share knowledge. I always look forward to opportunities like this. My voice might be a bit low because of where I am at the moment, a workspace. So I don't want to, you know, make so much noise. I'll be as discreet as possible. But trust me, we have solid content to share today. So, last month reInvent, we had reInvent is like the biggest AWS event in a year, every year. So it holds at Las Vegas, and at reInvent last year, they they kind of like introduced some new services in AWS and in terms of storage, compute, and many other services. But in this case, we'll be covering new storage for AI, ML, EFS, and archiving. I'll go straight to it. My presentation is going to be very, very short, but you'll get the message in the end. Um, So what's AI? What's machine learning? Everybody's talking about AI right now. ChatGPT is a very is a very popular example to how AI has actually affected or impacted the lives of the workforce. In fact, almost everybody. So was AI, was machine learning. So artificial intelligence is basically um, a system that is kind of like a synthetic system for that has human-like intelligence. So it's kind of like human-like synthetic human-like intelligence. So human intelligence is we might call that as natural intelligence, and when it's synthetic, meaning when it's from a machine, it becomes an artificial form of intelligence, right? Please, can I have this my whoever is moderating, please, this my image here. Just put it on the low right corner, please, so the the presentation or the slides can be bigger. Moderator, please put my image on the low right corner. Thank you. Great. Looks good. Okay, so when we say artificial intelligence, it has a lot of branches. Like if we go deep, is a very very deep topic and it's a hot cake at this moment. As we know now, Nvidia, which is a GPU creator, a chip creator, is like one of the most has become one of the most valuable company in the world. I think it hit $1 trillion some weeks ago. I think it's the sixth or the ninth most. Yeah, it's the ninth most valuable company in the world. So if we look here now, machine learning has artificial intelligence has different branches. There's machine learning, which also has a subset of something called deep learning. There's expert systems. There's natural language processing, which has several subsets of text generation, question and answering, content extraction, classification, machine translation. To an extent, ChatGPT uses some form of natural language processing to really understand, what the context of whatever prompt you give it. The speech recognition, text to speech, speech to text. There's planning, there's robotics, and AI vision. Also, vision is also a very important thing in terms of machine vision and machine vision. So for me, I think the end goal for this is trying to replicate human senses into a machine. So for now, we probably have the brain, which we can now call artificial intelligence. The brain. We have the vision. Computers can now see, or machines can now see. Machines can now speak, right? I don't know if there's anything yet for smelling. But I strongly believe that we're getting to the point where we want to synthesize human senses into a machine. you know so next slide. Yes, so model size, this graph is not so clear. I got it from some AWS presentation, but it basically is just showing how much data has been needed in terms of like training models, from 1957. Just so you know, artificial intelligence didn't just start in 2019 where ChatGPT was launched. I mean, artificial intelligence has been around for a very long time. I think in the 1950s. So these are the amount of data, they've used to train the models, and then it keeps growing and keeps growing. And now we have this kind of what they call this kind of curve in economics, but it's a very steep curve going up there, meaning that the amount of data available to train machines is now very large. So the size of data actually does matter, and that's where storage actually comes in. Um, why storage? Why storage is important for Gen AI? By Gen AI, I mean generative AI, and ML means machine learning. So here you can see we have prepare. prepare your data, you build, and then you train, and then you deploy. So that's kind of like the process of how the ops part comes in, like the ML ops part comes in, and the underlining. Okay, now I see why Imo actually said my image is actually covering some parts of this slide. Admin, please can you just take it back to how it was before? Because you were actually right. My image is covering some part of the slides. This is looking small. Yep, good. Thank you. Thank you so much. So that diagram kind of like shows the process or the workflow of ML ops, and underneath there is data, because data actually holds a lot of weight underneath it is storage, because storage actually holds a lot of weight in that process. So from the preparation to building to training to deployment, there needs to be some form of storage across board in throughout the entire workflow. So why then is it very important? It's because of data storage. At this point, you still need to store some data. At some point, the model would need to be stored somewhere, right? Model can't be on thin air. It needs to be somewhere. I have this ideology that everything has some form of storage. If you think about it, everything is stored somewhere. You're as a human being, you're stored in planet Earth. The Earth is stored in the Milky Way. The Milky Way, there's something just wrapping around something to hold it. You get, so that's my own ideology. So training, data versioning, real-time data processing, all of these stages in a workflow would actually need some form of storage. So storage is actually very important. As much as compute is important in terms of training the models, the compute system depends on some form of storage availability that actually holds the data that is being processed. Um, so the role of storage in ML was still in the same, what's the word, the same box at the moment. So in this diagram here, on the left hand side we see storage, on the right hand side we see a GPU or a CPU cluster, which is I actually refer to as compute. So compute is actually the CPU or the GPU cluster, yeah, and then storage where you actually get in. So from the storage side of it, efficiency and checkpoints, efficiently stores checkpoints. So what that means is that if we go back a bit in this process, in this workflow here, where we have prepare, build, train, and deploy, uh, there's an efficiency in this stage to store like the checkpoints, right? So kind of like having some form of retentive memory, you know. Um, on the GPU side, it keeps the GPU busy. So if you just have bare compute that isn't processing some form of storage or some form of data, you're just wasting money. You're wasting money. You're giving your money to AWS because the CPU would just be there computing nothing. Well, hypothetically, you can't really compute nothing. If there's compute, there needs to be some form of storage, uh, you know, where it gets its data to process. So on the right hand side, we see that it keeps the GPU busy. So this is basically just the process of training the data. From training the data to the checkpoints goes to the next stage of the workflow. Train the data to the checkpoint, that kind of thing, and then that's how storage and the cycle actually works. Um, so I hope my voice is clear. So I'm trying my best not to be too loud. Yeah. So okay, I saw something. Okay, so you can't talk about machine learning on the cloud, specifically AWS, without mentioning SageMaker. I mean, SageMaker is very important, and it does the process of data preparation. In fact, it's a seamless end-to-end workflow from data process preparation to training the models to deployment and then monitoring it. It has that ML ops capability. So what is SageMaker? It's a fully managed AWS service that simplifies the process of building, training, and deploying machine learning models at scale. So when you say at deploys at scale, that's where cloud comes in. So in terms of scalability of your compute or other resources and the entire system. Okay, am I just got. Sorry, give me a minute. Okay. So it's not really me. I'm still live. So I'm going to give you an example. Okay, thank you. I'm going to give you an example of like a customer journey to the cloud in terms of machine learning. So on the left side, there's a lift and shift file system customers. We have some customers who probably have like on-prem setup. By on-prem setup, I mean they're not really on the cloud, right? They have bare metal compute and everything somewhere, locally. So their strategy is to do a lift and shift in the sense that they when they want to get to the cloud, they basically would want a storage, a file system where they can just copy exactly what they have on their on-prem service or on-prem servers, and then just paste exactly as it is the file system on the cloud. And we have AWS actually have a service or a service that actually fits that side of the customer. And then we have customers who basically use S3. That's S3 data lake customers who store their files as objects. you know so in the cloud, there's like three forms of storage. There's file storage, there's object storage, and there's block storage. Block storage has to do with your hard drive, that kind of thing. EBS, we have a service called or product called EBS, as elastic block storage. If you create an EC2 instance, it automatically has that volume attached to it. Hard drive, SSDs, they store files in blocks in a sense. And then there's file storage system, you know, how you store your files and all of that. And then there's S3, which stores data as objects. So you can store your image as an object, your websites and or whatnot just as objects. You get the idea. So these are like two types of customers that would want to get into the cloud, and this is like some form of like where how they actually operate. So lift and shift, copy and paste file system customers, and then an S3 data lake customers. So we have two kinds of storage services that would actually help these two types of customers. um, I don't like it when there's too much text in the slide, but I have no choice but to put text. I'm just gonna read what what I have there. So benefits of FS. Oh, I think I missed something. Give me a minute. Let me see this. So this slide is supposed to copy for the order. So to let me come here first. So to the service for the lift and shift file system customers is what we want to talk about now. And we have something called the Amazon FSX for Lustre. I don't know if I pronounce it well. It sounds French, but it's fine. So FSX is kind of like a file storage. That's what I mean. FS file storage system for Lustre is optimal for machine learning workloads. So it's actually designed for machine learning workloads because it provides shared file storage with high throughput. So keyword there is like high throughput and consistent low latency, because you are training a huge number of data sets. Throughput and low latency is actually very, very, very important in the entire process. So to have an effective training of those data sets, ML data sets, you need to have use something that stores files in a file system format, right? So we have this service called Amazon FSX for Lustre. Um, so I'm going to come back here. So the benefits of this, why do I need to use this thing? What's the point? So number one, it has the capability with it's compatible with virtually every ML application. So compatibility is one thing. It's intuitive and consistent data access for researchers and developers. As two, three, it is fast. It is scalable random data access across files and within files. So what that basically means, you have a lot of data sets, and you can it's easy to access. It's really fast to access most of those data, even when you are like scaling your data sets. And then number four, the price is also very important in when you want to choose a storage option. I mean, you want to choose something that is efficient, yes, but then there's something called FinOps. I'm sure you've heard about it. So FinOps, someone who kind of like does the operation of like trying to find like the most cost effective resource or cost effective systems to use in terms of implementation of their workloads. So different price performance options. It has a lot of options. Cost optimized to serve data for active training workloads. So cost is one thing. Fast scalability is another thing. The fact that it's compatible with every ML application, and then it's easy to use. Has this intuitiveness for researchers and developers to really easily adopt. Okay, so been here before. Good. I wish I can zoom in. Okay, let me see if I can expand this. So this diagram, yeah. So this diagram actually shows how it works, right? Very comprehensive diagram shows exactly how it works. So on the left hand side, we have the Amazon FSX for Lustre. So the first thing you do is you create your file system using the AWS Management Console or your CLI or the CDK. From there, you can then link your file system to an Amazon S3, which is kind of like optional. I think I have a slide that, okay, yes, we'll come back to this. So it's optional to link your S3 buckets to that file system for extra form of like storage, and then link your file system to your yes buckets to help you process your S3 data sets. And then from there, you can then connect. You can either connect it directly or you can connect from S3 to your compute instance. Like I said earlier, compute actually needs some form of volumes or some form of storage to where it's gonna be reading data from. Compute can stay idle. So in this case, compute instances like your EC2, your ECS for containers services, then EKS for um, Kubernetes. Also, for on-prem clients can also still use that. I think we have AWS Outpost, which is a like on-prem an on-prem service. So if you have like bare metal on-prem service, we can easily bring AWS services into your local on-prem infrastructure. So you can then give access to your file system through your compute service, and then you can then connect to other resources like SageMaker, AWS Parallel Cluster, AWS Batch, Nimble Studio, and all of that. So this kind of like shows you the process of how you can do most of these things, how you can use Amazon FSX for Lustre. So one thing you need to note is that data sets are actually stored in like a file system format. So it brings us to this very interesting image, which kind of like complements what we have here in a more visually comprehensive manner. So on the left hand side is where you have object storage, which is Amazon S3. As you can see there, up here it stores files, file one, file 2, file 3 as an object, and then we you can then connect that S3 bucket to FSX for roster, and then take that data straight to uh, your compute service, which is Amazon EC2. So it's just, you know, complementing what I already said here. Um, so before we come here, I'm going to go back a few steps in my slide to explain the other part of the other type of customers. So S3 data lake customers. So these are people who actually use S3 without some form of like file storage, FSX file storage system. So we want to talk about the products designed for them, and that product is drum roll Amazon S3 One Zone. Amazon S3 One Zone is kind of like a storage class. It's a new storage class that was announced last year at reInvent, and it's the shiny new storage class. We're going to talk about it. So yeah, so this is just showing Express Zone compared to the others storage class. Yeah. So what exactly is Express Zone? What's Express One Zone? What exactly is it? So Amazon S3 Express One Zone is a high performance, keyword high performance, single availability zone. That's why you have the one there. Do you get? That's why you have the one there in the naming. It's because it's for a single availability zone storage class. Pre-built to deliver consistent single-digit millisecond data access for your most frequently accessed data and latency sensitive applications. So if I'm going to draw out some things that should take your attention in this definition, the naming Express One Zone, the one there is because of single availability, is a single availability zone storage class, right? Second thing I want you to note is the single digit millisecond data access, which actually means that it's very fast. It means it is very, very fast. I think it does 10x. Um, that should be in the next slide here. But it's very fast in the sense that your most frequent data um, would be your most frequently accessed data is like has some less latency, meaning you have less lags in kind of like assessing or retrieving data from S3. It's very, very fast. So things like GPUs, machine learning GPUs, training chips, those kind of things would need a storage class that can actually match that performance. And latency is going to be something very, very important. So this is where latency is sensitive. So Amazon S3 Express One Zone benefits. What are the benefits? I already said some of it before, but the first thing is accelerated performance critical application. So you might be like, okay, there's just too much information here. There's too much information here. I'm just going to rough it up. It gives you accelerated performance. So it improves access times to application by up to 10x compared to S3 standard. So it's 10 times faster than S3 standard. Second thing here, which is point number two, is that the lower total cost of ownership. So with the fastest data access, more efficient of use of compute resources, and lower API request costs. So it's just very cost efficient. You can access your most frequently accessed data at a lower overall cost. So in terms of storage, if you've written some AWS exams, you notice that the cheapest in all the storage class is AWS S3 Glacier, which actually does archiving. Your least frequently accessed data goes to archiving, which is Glacier. I think that costs like $1 per terabyte, which is very, very cost effective. But now we're telling you that we can actually give you high latency and high speed at a very low cost, right? So that's what one of the benefits of Express One Zone. Um, scale, scale simply without provisioning. So elastically scale to process millions of requests per minute without any pre-provisioning or modification of existing applications, and use familiar existing Amazon S3 APIs. So like like we said, scalability, elasticity is something very important, and it's a benefit that S3 Express One Zone gives to you. This is my last slide, and this shows you the process of how this thing actually works. So applications require low latency performance for a subset of frequently accessed data, right? So the S3 API, um, applications access S3 Express One through the S3 API. So it uses the S3 API to access Express One, and then once it accesses Express One, which is usually is in a single availability zone, like when you want to create an S3 bucket, you usually would pick a region where you can actually drop your S3 bucket or create it in. But this time you can now do it in a zone. So if your compute instance, for example, your EC2 is in a specific zone, not just a region, we've singled it to a zone, you can now create an S3 bucket inside of that zone. Instead of having an holistic view from the how do I put it, from the region, right? So region, we have regions, we have availability zones, which comes underneath it. So Amazon S3 Express One Zone in your availability zone, and then you can co-locate storage with compute to reduce latency. And then from there, you can use it to connect to your generative AI training models, and transactional tables, data lakes, video content, financial model simulation. These are just examples of things you can do with it. The point is your S3 bucket is closer to your compute instance as possible. That reduces that latency. So that's pretty much it, and I'll say thank you so much. But what you need to know is FSX for file storage system, FSX for lost or file storage system, and then we have Amazon S3 Express One for people who use S3 data lake. So those are the two the two major storage classes or storage services that were announced as we invent, and very shiny new stuff. I think you should go around, play around with it, and see how this can actually benefit you and your company. Thank you. Thank you, Latif. Are you there?
Yeah. Okay. Thank you very much. This quite really interesting and very educating. I paid attention to everything, and I hope everyone on the study session also did. We've been able to jot one thing or the other. Yeah, pretty. I found it quite interesting because I'm one that is very interested in the aspect of AI and machine learning. I could relate with a lot of things you were saying when you were talking about different storage, the part of the machine learning training process using AWS SageMaker, and how helpful checkpoint can be in case of disruption whereby you meet up with where you've trained your data with. So I will like to ask the audience to send their question through message to the chat box, so that while we await before we have our quiz session, we will have some questions. If you have any question about what Ukemi has discussed to this evening, so that I can give clarifications to where necessary. Yeah. Okay, one interesting thing that I found while you were sharing your discussion was the new storage class. I actually missed that. I didn't know, and in my mind, I wanted to ask. Even though you are trying to make emphasize on the key point with respect to the express, but I want to say, can you please just shed more light how it's better off the standard, and if you are considering one zone, how it's better off the one zone storage type? I don't know
Okay.
if
Yeah,
yeah.
that's a good question. So if I'm going to repeat your question, you're saying what's the true benefits using Express One Zone compared to standard? I said that earlier. When you want to create a standard or any
Yes,
other type
yes.
of S3, you create it in a region, right? Not in your availability zone. So the reason why it's called one zone is because you can create it in a single availability zone, which actually means that your S3 bucket is actually closer to your compute. So when you're creating a compute instance like EC2, you create it in an availability zone, right? You choose the region, and then in that region, you choose the availability zone where you want that to be in. So if your compute and your S3 object storage is in the same availability zone, it reduces latency, right? And then there's fast
Okay.
communication between that two. So that's what you have that standard doesn't have.
Oh, great. Okay. Thank you very much. I don't know. I've not seen any question from anyone. I want to guess what you've shared has been quite understanding to people on the call. But if there's still any question, please feel free to share, to send the message so that Okeme will be glad to answer them. Uh, I think pending while we wait, we can have uh, our quiz open up so that we can manage our time well. So please, let's drop our question if we have any. Um, so I want to believe the topic for today is one that interests everyone like myself. So we should have quite a number of things to ask about it.
I mean,
And
if no questions pop up, we can as well assume that everybody understood understood the concept. So,
well, I think might be quite safe to assume that. Okay, awesome session. Thank you. There's someone else verification to enjoying you or understanding.
Bolaji, thank you.
Yeah, yeah. Okay, so anytime from now, we'll be dropping. For every session, we do have a quiz, and we hope um, we hope we are ready to join. So, in any moments from now, we'll be having our links to the quiz displayed. So, please let's get set. Hello. So we are still anticipating if anyone asks any question so that we can take it before having the quiz. Um, Balaji, thank you for joining the session. I can see I saw your message at the beginning and I can see your message at the end. Yeah, similarly to Ejiro again, thank you for being with us all through. Fatima Abdul from Kenya. Wow, that's quite a distance too. Thank you for joining us. So I hope from what our speaker has been able to share with us, we'll try to get our hands, lay our hands to try out some of these things that he has mentioned, and I'm hoping that also for some of us that will be able to benefit from the reward of the quiz that we will be having. We will have the opportunity to also use whatever we gain to practice. I have been one of the beneficiary of this in the past, and I know how helpful it has been to us putting some getting our hands dirty, like they do say, to test out all these technologies. Yeah, yeah. Well, okay. So just something between. I don't know if there's anyone who applied for AWS Community Builder in the house, and yeah, I think there was quite a feedback. I don't know. I was not like in a normal way. I actually received a love letter, but I'm sure I'll put in more effort to handle. I don't know if you know if you all understand that times when you get a love letter from an application, but it's not something to discourage, but to put in more effort. But I don't know if there's anyone that got accepted. Congratulations to you. And for we that received our love letters, yeah, it's just true that we just need to put in more and reapply when in the next opportunity, and hopefully, we get into to be more impactful into the community. So, please, sorry, we are still trying to have. Yeah, thank you, Bolaji. Thank you for that affirmation. Yeah. All right. Sorry, please. Oh, oh, I just get the confirmation that we won't be having our quiz today. I think that it will be postponed till tomorrow when we have our session tomorrow. So, um, and it was not intended or intentional. It was due to some technical challenges. And whilst we don't want to waste our time staying on the call, we will just find a way to sort it out tomorrow. Maybe the number of winners will be extended to two. I don't know. I'm just saying, depending on what the admin decides to do. So once again, I want to thank you for let's joining today's study session. Thank you for listening. Most thanks to our speaker, Okeme David. Thank you very much. Uh, I know you're at work and you still did a perfectly great job. You didn't leave out the vibes. I can remember when you were talking about the one zone. I was feeling you, and yeah, I hope others did too. So once again, thank you very much. Thank you for sharing this with us, and we've really gained. I myself and others have gained, and I want to encourage all people that are joining to try and follow us for we have our session tomorrow. And for tomorrow's session, we'll be having Samuel Mudukwe to discuss with us overview of quantum computing built with Amazon brackets. I don't know. So I think that's one of the new service or tools that AWS has released recently. So I hope we'll join in to learn from our speaker on that topic. So please, same time, 6 p.m. West Africa time, and invite others to join. So I will, and lastly, don't forget to follow us on our social media pages, and the links will be dropped in the chat box for you to get through our different social media so that you'll be aware of our various activities. Once again, thank you everyone. Thank you for joining. It's been a lovely time from here, and I look forward to see you the next time. All right. Bye. 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 Thank you.